Hi children, good evening all of you. I hope today is the decision day for all of us. And I do understand that when you are preparing for integration, we definitely try to recollect something and forget a lot of things. So here, just with a lot of efforts, I'm going to take you through the synopsis of a complete indefinite integration touching every exercise. Few examples, definitely not possible to take up maximum examples. So whatever examples belongs to that particular type of exercise, so those sums we will be coping up with. So definitely what you are going to gain from this, children, you will be able to get the synopsis of the complete indefinite integration covering the core methods of integration and the special integrals. So core methods of integration, what you have, here we see. What you have, here you are going to see, as I said, the core methods which has the full set of core methods available here. This particular coverage of your topic is basically the 14th topic, which is nothing but standard methods of integration. Now in that you see the long division method, you see the substitution method, you did the eyelet rule also. I mean to say integration by parts. Okay, in integration by parts there are different things also. You can see this, or every type I had covered in this complete indefinite integration revision here, and I believe that this is really going to help you a lot. So let us begin with the first type of particular pattern of sums is nothing but the substitution technique. Now look at this particular pattern, substitution technique. The first part. Which exercise is dedicated to this? The dedicated exercise is 14A and 14B is completely dedicated to that is on integration by substitution, as well as this also. So both the exercise, both the things you can see, it is 14A, 14B. Keep that in mind. Okay, so let us go one by one. I will come back to this chart whenever is required here. So 14A, 14B. So what you see in this particular chart is, these are the core methods, that is long division, integration by substitution and integration by parts. So the complete 14 topic is dedicated to this. It's very, very important lecture, very, very important type of sums in core method. So let us see how we go about it with the first question of integration. Now based on 14A, I beg your pardon here, it is based on 14A, okay. Now what does this 14A consist of? Just in a short span I will just tell you. So whenever in the integrand the function is there and its derivative is also there, or whenever in the integrand the function is there and the derivative is also there, I mean to say in quotient form or product form, whenever the function and the derivative is present in this, then you compulsory do the integration by substitution, okay, by substitution. That's why I mentioned here 14A exercise, substitution and long division. I mean to say I just long division I have to add up there, I am sorry for this. So long division, okay guys. So what we do, how we do, we can see that. So as I said, this is called as the integrand. So in the integrand, if you have the function and derivative either in quotient form or in product form, then I say I do the integration by substitution technique. Now what is the substitution technique? You put the function as t and then proceed. So let us quickly rush through or go through the sums which I will be putting across. Now I'll just keep this for you now for your reference. So as I said, just to share with you, what we are doing is, that is when the derivative and the function or derivative upon function exist, you do integration by substitution. guys. So here we go. Let us see now how we go about. Now look at this particular sum. It looks a simple question. Yes, it is indeed a simple question. You have the function tan inverse x and its derivative 1 upon 1 plus x square. So I mean to say it belongs to the first category. So whenever the function and the derivative exist in the integrand, I go for substitution. So what I do is, I will say let tan inverse x be as t. Now what happens once you do the substitution, you have to find the derivative. So tan inverse x derivative is 1 upon 1 plus x square is equal to dt by dx. Remember, I am differentiating both the sides with respect to x. So tan inverse x derivative is 1 upon 1 plus x square is equal to dt by dx. Now eventually, what is the idea behind taking the derivative? Take this dx here. So 1 upon 1 plus x square dx is nothing but dt. Now what you see guys over here, you see that 1 upon 1 plus x square dx. So 1 upon 1 plus x square dx can be replaced by complete dt. So that means 1 upon 1 plus x square dx can be replaced by dt. Okay, great. What is left out? Tan inverse x. And what is tan inverse x, guys? That is t. So I think with see this integrand and see this integrand, which is the better and easier way to integrate? Definitely, without any doubt, the second one. So children, the journey has started with indefinite integration, complete coverage, starting from the 14a exercise to 15g exercise. Okay, so let us start with this now. So as I said, integral t dt. So everybody knows you have to apply the power rule. So it is t square by 2 plus c. So my integration is done, but my answer is incomplete. I have to replace t. So t is nothing but, implies it is nothing but tan inverse x whole square upon 2 plus c. So this is what exactly the answer is here. That is okay, very important and clear cut. So whenever an integrand has a function and a derivative, you use the substitution technique and do it. Let us take some more examples so that it gets into your nervous system, children. Remember children, we are doing complete integration here, complete revision of integration with every exercise, example referred to every exercise. I am just putting across and trying my level best. Now look at this sum. Now definitely denominator is not welcome in integration, but I do understand whenever you have to integrate, always remember the core methods which I told you. These are the core methods: long division, integration by substitution, and integration by parts, So keep this in mind. So whenever you want to integrate, you have to look at this particular core method. Now when I look at this, it's definitely not an idea what to do with this. So whenever every road stops for integration, I believe that integration by substitution always comes to your rescue. So how I go ahead with this? So what I'm going to do is, if you see in this complete function, this xex is little bit complicated. So if I say let xex be t. So if I say let xex be t, so what I'm going to do, I'm going to use the derivative by uv method now. U derivative of v plus v derivative of u is equal to dt by dx. As we go on, I will be skipping this step of writing dt by dx. I will directly take the dx over here. So in short, what happens if I take ex common, this is x plus 1 dx is equal to dt. Wow. Now look at the sum. You look at the complete numerator, x plus 1 dx, x plus 1 dx. This complete can be replaced by a single term dt. That's what the idea of substitution is. Whenever you are substituting and you take the derivative, this part should replace something in the sum. This should be replace something in the sum. Otherwise, this substitution is of no use. So here, when I saw this, when I did xext, this complete numerator got adjusted with this stuff. So quickly now, so I am going ahead now. So this replace this by dt here. So dt upon this is nothing but cos square t. Now everybody knows that denominator is not welcome. So I can say this is nothing but sec square t dt, and everybody knows what is integral sec square t. I think that's the assumption or presumption I make, that you know integral sec square. So integral sec square t is nothing but tan t plus c. Now replace t and then say he. So what will happen now? Tan of x e x plus c. So this is what I want to share with you. This is what I want to tell you. This is what I want to show you, how the integration of substitution works. Remember, these sums are based on the first exercise, core method, substitution technique 14a and 14b. Let us take some more examples, but before that I hope you got this point, children. So pause and note it down. Let's take the next question now. Here we go. Sorry for this, but fine. Oh. Okay, now as I said, based on 14a and 14b. So 14a. Now look at this question, looks very complicated. As I said, when the sum looks complicated, you don't have any core method attached to it, substitution can be a rescuer. Now for example, in this sum, x squared tan inverse x cube upon 1 plus x raised to 6. Now what I see is, x square is there, x cube is there. What is the derivative of x cube? We can think of the other things later on. What is x cube derivative? X cube derivative is 3x square. So what I can do, if I put tan inverse x cube as t. So what is the derivative of this quickly now? Now before that I just want to share, I can write this as x inverse tan inverse x cube divided by 1 plus x cube whole square dx. I am just writing this so that it becomes easier for me to deal with it, right? So I think what I can do is, if I put tan inverse, instead of saying tan inverse x cube as t, I would suggest for this x square here, I would put x cube as t, that would be better than, right? If I put x cube as t, so this will get completely okay. I think let us go ahead with the same substitution which I am trying to pursue. I will put tan inverse x cube as t. So what is the derivative of this? What is derivative of tan inverse x? Tan inverse x derivative is 1 upon 1 plus x square. So 1 upon 1 plus x square. Now if you look at this x square, the square of this is x raised to 6, and by chain rule x cube derivative is 3x square. I took the dx up here, this will become dt. Now if I want carefully observe this, I just want to write this properly. X square upon 1 plus x raised to 6 dx is nothing but dt upon 3. That's a game changer. Now what I said, you see tan inverse and its derivative is down. So that's why I put the function as t, and 1 upon 1 plus x raised to 6 will be the derivative of tan inverse, and then go inside, the chain rule says 3x squared dx equals to dt. So guys, that's about, I don't want not interested in 3. You know why? Because if you look at this, x squared dx upon 1 plus x raised to 6. X squared dx upon 1 plus x raised to 6 can be completely substituted by dt by 3. So that's the game changer there. I mean to say, that's the benefit you get by substituting and finding the derivative of it. So guys, here we go. So I think x squared dx and this complete thing remains substituted there by dt. So I take this number out, dt. And what is left out here? Tan inverse t. Tan inverse t. I think I missed one point here. I think you can go ahead with lots of way of working, not a problem, but tan inverse t dt. Now what I am going to do is, I am jumping now tan inverse t, you can't integrate it quickly and directly there. I have to be very careful, because as I want to say, as I work, core methods are there. Now if I am jumping there, now I am not working on that, I will come to that later on. Now if you look at this in integration by parts, if the log and inverse are standalone function, you take the function as it is and into 1 and then do uv. Remember, inverse derivative, inverse integration does not exist, inverse derivative exists. So that's why there is a catch here, this is tan inverse t. So actually the integration has to be done in this format, tan inverse t into 1 dt. And then I go ahead with the normal substitution and work. I mean to say normal UV, integration by parts, and work with the sum. So this is what exactly, try to understand this what I had done and just work out the way you feel better about it. Come on quickly, understand it quickly. I give you 1 minute. Right. You might ask me, sir, why I have skipped that. I'll come to this particular solution once I come to that nature. Right now I am talking about substitution, how I just simplified this integrand to tan inverse t. Now how I integrate inverse standalone function, you do into 1 and dt. I'll come to that later on. Now let us take this one. Now if I look at this particular sum, sin 2x upon a square plus b square sin square, looks very complicated, but I know sin squared x derivative. What is sin square x derivative? Remember, in this case a and b are numbers here, so don't confuse. So sin square x, what is derivative of sin square x? 2 sin x cos x. So I think 2 sin x cos x is sin 2x, so it's get adjusted. So I believe there is something, a case of substitution here. So let us see now. If I put a square plus b square sin square x as t, I am taking the complete set of t. You can take b square sin square x as t, I have no issue at all. Because a derivative is 0, because after substitution you have to take the derivative. So this is 0, this is b square. What is derivative of sin square x? 2 sin x cos x into dx is equal to dt. So 2 sin x cos x, I believe b square, this will become sin 2x dx is equal to dt. Now you have to be very careful that whenever you are doing the substitution, it should replace something in the numerator. So sin 2x dx, now look at this sin 2x dx, sin 2x dx. So I can just make it look more simpler by writing sin 2x dx as dt upon b square, because b square I can always shift because I am considering it as a number or a coefficient. So in this case, what happens now? In this case, sin 2x dx will become 1 upon b square. If as I taken this 1 by 3 outside and then I worked out, so I can say 1 by b square is nothing but dt, because sin 2x dx is 1 by b square dt as per this statement, upon a square plus b square sin square x is nothing but t. So I think everybody knows what is in t is a linear function there, so dt with respect to t. I mean to say function derivative of integration of 1 upon t with respect to t. So what is integral 1 upon x dx is log x. So integral 1 upon t dt will be log t. So 1 upon b square, this will become log of t plus c. Replace t. So 1 upon b square, this will be log of a square plus b square sin square x plus c. Now this is the final answer for my stuff. I am coming to this integration later on. When I come to this type, I will come back to this sum and solve this for you all. It is not a difficult task, but as of now we are focusing on substitution 14a and 14b. We are just pursuing it further. So I hope you got this sum, the 4 sums of core methods of integration. The substitution here, if you look at this substitution gang, substitution working, substitution procedure, right, that's the way it goes. So I believe 14a is there. Similarly, let us take some more examples here, but before that, if you look at this particular case, here substitution may not work because you think, because see, one you do by substitution, you cannot do by long division. So initially now, as I said, we are focusing on the core methods of integration, guys. This part we just did. Whenever function and derivative happens to be the integrand, you put the function as t and then by substitution you can integrate. The next case, you look, what is it mentioning here? Degree of the numerator is equal or bigger than the degree of denominator. We do long division. What we do? Long division. Okay, long division, this is 14a, 14b I mentioned here. Long division, and after doing the long division, you write the answer as quotient plus r upon d, and then integration becomes very easier for us. Okay, so keep that in mind. So whenever the degree of the numerator, degree means maximum raised to power, degree of the numerator is equal or bigger than the degree of denominator, you can use this technique of long division. Let us have a example put across. Now look at the degree of the numerator. What is the degree of the numerator here? 4. What is the degree of denominator? 2. That means degree of the numerator is bigger than the degree of denominator. So I have to do compulsory long division. Remember, we are still doing sums based on 14a and 14b. So as I said, I have to do the long division. Everybody knows how to do the long division here. So this is x raised to 4 plus 1 and this is x square plus 1. Now I have to do the division. I hope everybody knows it. So I'll take the first term as it is. So x square, whatever the quotient, multiply by the full divisor and place in the dividend. X square into x square is x raised to 4 plus x square. Minus sign as per normal practice. This cancels there. So this is minus x square plus 1. You can continue the division till the degree of the remainder is less than the degree of denominator. So here it is 2, here it is 2. I can still divide here. Put the minus sign here. X square 1s are minus x square minus 1. I believe 1 into all that stuff. With the sign plays a very important role. Cannot ignore the sign. So this will become plus. This will become plus 2. So I believe now I cannot divide further. So this is my quotient, this is my R, this is my divisor. So remember, once you finish with the long division, you have to write this complete set. You can write as Q plus R upon divisor. Okay, keep that in mind. So let us place my point here. So what is the integral here? Quotient plus remainder. Remainder is plus 2. Upon divisor is x square plus 1 dx. Remember, the integration here was a tough task for me. But by using the technique, look at the integrand, what happened. It has just spilled up. The integration here is more easier, children. Bet it. I will just prove my point here. So integral x square minus 1 plus 2 upon x square plus 1 dx. I can say the integration of x square is x cubed by 3 minus x plus 2. What is the integral of 1 upon x square plus 1? I think the standard values or formulas of integration you should know. Dx upon x square plus 1 is tan inverse x. In short, derivative of tan inverse x is 1 upon 1 plus x square. So what is the integral 1 upon 1 plus x square? Tan inverse x. So I believe it is tan inverse x plus c. So this is what exactly I am looking upon. The answer here, guys, I don't want any messing up. So long division is a important sum, important type, you can always remember, but be happy when you get it because everybody knows how to do the long division and then you can process this out. I hope you are understanding it. Let us take the next question. So once again here also there is a clue, that is definitely the degree of the numerator is definitely 6 here, degree is 2. So definitely this has a case of long division. Remember, this you cannot do by substitution. So let us go ahead with this now. So x raised to 6 minus 1 divided by x square plus 1. So I believe everybody knows the x raised to 4 into x square. Multiply the quotient with the complete divisor. So this becomes x raised to 6 plus x raised to 4. This is minus, this is minus. So minus x raised to 4 minus 1. Let us do the further x square here. So minus x raised to 4 minus x square. So quickly here plus plus. So this is x square minus 1. Still I can divide further. This is x square plus 1. So this is minus 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 2. Now remember, this division I assume and presume and ensure that you know it, and that's why I'm not just going digging it further. So let us dig the sum now. So as I said, once you finish the long division, you have to write the integrand as this, because if you simplify this, you are going to get this sum back. I don't want this sum. I want to come back to this. So let us see what happens now. So integral quotient. So quotient is x raised to 4 minus x square plus 1 plus r. What is r? Minus 2. So you can just put minus 2 upon x square plus 1 dx. Now look at the way the sum has blown up. So simple it is to integrate. Every term you can integrate separately using the power rule, and of course wherever standard forms are there. So in short, let us do the integration here. This is x raised to 5 upon 5 minus x cube upon 3 plus x minus 2 tan inverse x plus c dx upon x square plus 1. Just now we saw how we integrate it up. So that's the game changer here. It's not difficult. Have a look, understand what technique it is, understand when we do this, use this technique. So that's what you have to keep in mind when you see a sum on integration. We are going to see every type today, every type. Might be matter of couple of hours, but definitely it is going to save your 20 hours later doing nothing in integration. Okay guys, so this is a promise from my side. So I hope you got this point clear. Remember, we are dealing with core methods of integration. Once again, I want to remind you, core methods, the 14a and 14b, where we see substitution and long division technique of integration. I hope you got this message clear. Just pause and note it down and just digest it out completely. Okay guys, I think the core method you have understood, the substitution and the long division. Let us see what is the next core method in store for us. We are finished with 14a and 14b. Remember, I am not doing all the questions here, just it's a revision type of thing covering every type. Okay, the next is, this 2 is over. The next is very important and very interesting. People love it because it is very easier to understand and much comfortable to do. So, what is this? This is called as integration by parts. What is this called? Integration by parts. Integration by parts. Now, when I say integration by parts, ka matlab kya? Product rule. In short, you have two functions inside the integrand with a multiplication sign. It's a product rule. So, what is the formula for integrating this? U integral v dx minus integral derivative of u integral v dx plus dx. So, that's the basic game changer rule. But what is the important thing is, if two functions are given in product form, then what you will take u and what you will take as v, because if you see this formula or technique, you are defining derivative of u and you are integrating v. So what is the form or what is the technique of selecting which is u and which is v, because in the integrand there are two functions. So you follow the Liet rule. In some case they say Eilert rule. Eilert, Liet is one and the same. By the way, what Eilert and Liet stands for, it's mentioned here. Liet stands for logarithm, I stands for inverse, A stands for algebraic, T stands for trigonometric, E stands for exponential. So this is the order in which you have to take the function as u and v. So guys, so let us see how I look at it, how I look upon it. So that's the way, let us talk about this. But the point which I want to tell you, so you might also, why is the branching out? Because in integration uv, there are different categories of sum. So first category is a general. Everywhere you are using this uv rule only, but I'll just share with you. General, then whenever log and inverse standalone function, you do into 1, as you saw in the previous question of substitution. Here, if in the integration e raised to x sin x cos x form, then what we do? That is, we don't follow the Liet rule, and so each type I will cover up at least minimum 2 sums and make you understand how really we understand which type it is and how to do and how to contribute a solution for this type of sum. So let us see now. I'm talking about the next one. So 14ab is over. So I believe now we are talking about 14c exercise. Okay, 14c and d. Hopefully I'll just check it out with that now as we go on. So let us see the 14c question. That is, I believe, sums based on 14b. 14b is still there. That means my substitution has not ended. I'm sorry for it, but let us go ahead with the substitution technique now. Now, in short, here there is no product, so I'm not talking about uv now. Okay, there is a tan cube x. So how I do the integration here? So you have to use your brain, which is well trained. Can I write this tan cube x as tan x into tan square x? Right? It becomes easier for me to remember. You have to integrate, and power rule cannot be applied to trigonometric function integration. Integration applied, power rule can be applied only to algebraic function. So in trigonometric cube power, you become powerless. So I just split it out. Why I am doing this? Because I understand from here tan derivative is sec square. Because just now I saw in substitution, when a function is there and the derivative is there, I can use the technique of substitution. So as soon as I see tan square x is sec square x, and tan x derivative is sec square x. Because why? Because tan square x I can write as sec square x minus 1. Formula, basic trigonometry. So what I can do is, I can do this tan x, I can write this as sec square x minus 1 dx, right? So I think now important thing is how I do it. The best way, when everything gets closed, I think I open the bracket, the simple basic mathematics will come to a rescue. So what I'm going to do is, I'm just going to place it comfortably now, sec square x dx minus tan x into 1, you can just write this separately there, tan x dx. So tan x into this first term, tan x into minus 1 tan x. Now it's very simple now, everybody knows that integral tan x dx is nothing but log of sec x plus c, and integral cot x dx is nothing but log of sin x plus c. Keep that in mind. So as we go on, we will see. So now here, let us talk about the integration. Now I am not concerned about what is in the store. Okay, great. So I think it reminds me the previous part. Function is there and derivative is there, because tan x derivative is x square x. So here what I can do is, I can put let tan x be equals to t. So what will happen now quickly, children? It will become sec square x dx will be equals to dt. That means this complete thing got replaced with dt. So what happens now? This complete thing became dt, and this is nothing but t. Minus, I have no issue because integral tan, just now I saw it is log of sec x plus c. So integral tan x is nothing but log of sec x plus c. But I have to take the integration here. Definitely it's not a trigonometry here, here it is, but it's not here, it's an algebraic function, I can apply the power rule. So it will be t square upon 2 minus log of sec x plus c. I think this should not confuse you all, should not bother you all. It's a simple thing. I think everybody can understand this. So what is t? Replace t. That is nothing but tan x whole square upon 2 minus log of sec x plus c. So this is what exactly the answer will look like. So please understand it. I might be going a little bit faster because we have to really climb a very big mountain here. Remember what we are doing is, we are doing substitution and long division technique. I went into UV by fluke, but fine, I can come back to the point which I am giving here. So sin 2x upon, now here this part, I hope you got this message clear. Sometimes you have to really think over the integrand properly and see what best you can adopt the method and then go. Remember, core method is long division, substitution and UV, product rule. You will see that as we go on. Now let us take the next question. Now here when I see here, there is no long division. Any sum, see this is always I tell the children, whenever any sum is given to you, remember this chart. This chart is a Brahmastra for you. This chart is I would not say commandment as such, but definitely it's a way of looking at the integration topic, because when any sum is given to you, take that sum and place over here. Oh, long division cannot be applied. Therefore, I will then check whether I can do this method. Yes or no? No. Then I go and look at this and see whether it belongs to one of the category of the sum and then apply that corresponding technique. That's what you are supposed to do. So let us see now how we go about it. Now quickly, children. Long division out of question. Substitution, I really don't know, because sine derivative is cos. There is no question, because whenever you are integrating by substitution, remember you have to substitute something from the integrand. This is a very important point, not something from outside. Something over here only you have to substitute. Here tan x is there, I put the tan x as t. Any substitution sum which you saw, which you are going to do, you do the substitution for what is present in the integrand, not something from outside. So here there is no question of substitution, but I really don't know what to do. As I said, given you all the doors get closed up and you don't feel the technique also doesn't apply, then I see the basic mathematics always comes to a rescue. What I'm going to do is, now look at the angles here. 5x is there, 3x is there, 2x is there. I really don't know, but I'll try to work it out. So 5x is there, 3x is there, 2x is there. So 5x I can write out, 2x I can write as 5x minus 3x, then that gets converted into this format. So what I am trying to share, just see, I am just using my common sense here. I can write like this, because 5x minus 3x is 2x, and here if you see, this is sine 5x. This I really don't want to touch because it is like a time bomb. It will just blast off later on. So once you finish with this, now I have some hopes because sine of a minus b, everybody knows the rule of sine of a minus b. What is sine a minus b? Sine of a minus b is sine a cos b minus cos a sine b. I know you are all having a serious look at this formula, class 11 formula of trigonometry, compound multiple angles. So let us begin with this now. This is my a, this is my b. So this is sine a cos b minus cos a sine b upon, now this sine 5x 3x belongs to everything which is in the numerator. So this is the numerator there. So I'll just give this to both of them separately there. So sine 5x sine 3x, sine 5x sine 3x dx. Why I did this, you'll come to know right now. So if you see this carefully here, sine 5x gets eaten up here, sine 3x gets eaten up. Now what happens eventually, this is cos upon sine is nothing but cot 3x, because you have the integral of cot. So cot 3x minus cot of 5x dx. I think my integration is ready to come up. Integral cot. What is integral cot, children? It is log of sine 3x upon 3. Mind you, upon 3, chain rule. Cot integration is log of sine, and go inside 3x, derivative is 3. So in integration you divide by the derivative upon 3 minus, this will become log of sine 5x upon 5 plus c. There is another way, you can just find the LCM there, take this 5 here and game changer. Take the 5, whatever the LCM is coming up, or you can keep it as it is. So this form or that form, जो जीता वो सिकंदर इसके अंदर. So this is the solution for 14b sums. I mean to say, integration by substitution only we are using, but along with that something basics also we are doing. Like here, tan cube x became tan x tan square x. I applied the formula of trigonometry. Here also I applied the formula of trigonometry. Simplified the function. Nobody can stop you from simplifying. You don't think before simplifying. If you are able to do that, whether I do or not, you go ahead and simplify any function, any integral to the best of your ability, and then you can look at the question. No problem at all. So I hope you understood this 14b. Now the next part which I want to share with you is, before that, pause and note it down so that you have a grand look on this particular question. In the end, I will just share the code with you of this so that this notes comes up to you directly. So I hope you got this point. Clear, guys? So beware, be still and be confident. Okay? Now let us take the next question now. Okay, here it is 14c, that is integration by parts. So here also I am missing something, by parts. Okay, what is this integration by parts? I'll come to that now quickly. But before that, I took you back here. What is integration by parts? Just I explained to you. Based on this, you have general type of sums on integration by parts. Integration by parts, in short, to make you a easy local language, product rule. So when two functions there, use the product rule. Now in product rule, this is the way, the priority in which you take the function as u and v. Liet rule. In some textbook, it is given I late, inverse comes first. Both the answer remains the same, no issue at all. Okay, so let us talk about this now. Now, the first case which I am going to share with you is general and this, log and inverse. This belongs to 14c, okay. Log and inverse belong to 14c and 14d. 14c, now let us talk about 14c. The general rule now. So, before we proceed, I want to tell you, look at this function. Look at this function, x square cos inverse x dx. Now, if you see x square cos inverse x dx now, there is no question of substitution, right? So, what I am going to do here is, I can take one function as u, one function as v. So, Liet rule, remember, Liet rule, L-I-A-T-E, this is the rule. So, first log is u inverse. So, inverse comes first. So, this you will take u and this you will take as v. This you will take u and this you will take as v. So let us talk this now. So everybody knows the formula there, right? So you can have the formula if you want. Everybody knows the formula, that is u, I am writing u integral v dx minus integral box derivative of u, right? Integral v dx close dx. Now why this specifically box here? I want everyone to solve this portion inside. Remember this general uv, there is no specific nature of uv here. It is just two functions that are in front of you, straightforward. You are taking one as u, one as v, and then just integrating by applying the formula. So I applied it here. So let us quickly do it now. I don't waste my time. Cos inverse x, put a bracket here. This is x cube upon 3 power rule minus, remember whenever there is a uv rule applied, so the inside part I want you to solve this first. What is derivative of cos inverse x? It is minus of 1 upon root of 1 minus x square. This is x cube by 3 dx. That means that still the integration sign is hanging around. Now you have to be careful about this because the integration is demanded here. This is taken care of. So I'll just write this out properly there. X cube cos inverse x upon 3, minus of minus I can write plus sign, 1 by 3 I can take outside, any number you can always take it outside. It is x cube upon root of 1 minus x square dx. Now once an integration signs come into picture, you have to think about what technique you can apply for that particular thing. So here if I see long division out of question, but there is a root format here. So substitution can be a game changer. Now I am going for substitution. I will say let root of 1 minus x square be equals to t. So what is the derivative here? 1 upon 2 root 1 minus x square into minus 2x. Change, remember root derivative is 1 upon 2 root and then inside function minus x square derivative is minus 2x, dx is dt. Now let us see what is getting adjusted. This 2 will get cancelled there. So definitely x minus can go there. So I'll just write this properly there. X dx upon root of 1 minus x square dx is nothing but minus dt. I shifted this minus sign because I don't need that. The point which I want to mention here, when I am doing substitution, because something is getting replaced in the integral. If out of this x cube, 1x is getting replaced. So x upon root of 1 minus square dx is minus dt. So let me just write it out. Just see. So this is x cube, this no change, cos inverse x upon 3 plus 1 by 3. Remember, from here 1x dx upon this is nothing but minus dt. So what I am going to do here, this plus will become minus eventually and this will become dt. X upon this got adjusted. But what is left out here? X square is left out because out of x cube only one x in the numerator got replaced. Remaining x square. Remember once dt comes in the picture, all the thing has to be changed into t. So x square. Now look at the substitution here. Look at the substitution. Now I have to replace, the x square is left out because only x dx has been taken out and replaced by dt. So x square, how I get it? So from here I can say 1 minus x square is t square. So 1 minus t square is x square. So replace that because dt has come into picture. I can say 1 minus t square. Now integrating this is very easy. So let us do that now. So this will become x cube cos inverse x upon 3 minus 1 by 3 integral 1 dt is t minus t cube by 3 plus c. Now replace t, that's the over there. So this will become x cube cos inverse x upon 3 children minus 1 by 3, t is nothing but root of 1 minus x square, minus of minus is plus. So 1 by 9 because 3 into 3 is 9 and t cube, what is t cube? T cube is, okay, t is nothing but root of 1 minus x square raised to 3 plus c. So that's what the understanding here, that's what the catch is. That's what the answer looks for us in a comfortable zone. So what we are doing is general UV. Now remember I showed you before understand in integration by parts here, right, the first type we are covering is, that is nothing but general UV. Okay, so let us see now. General means U is also there, V is also there. You can identify using the Liet rule, you can do it. Now here also you can see. Now here I want to share with you something important. Now look at this, I am talking about 14C exercise, children. X cube derivative is x square, because x cube is 3x square. Remember, substitution by parts only are techniques of making the integrand simple, so that the integration becomes easier. So here x cube derivative, not necessarily you have to do this way. You can take one as u, one as v, one as u, one as v, no problem. Go ahead with uv. But I can make it more look better, solvable, comfortable zone. So what I am trying to do is, I am just going to go ahead with the substitution. Say, let us deposit x cube as t, because x cube derivative is x square. So 3x square dx will be dt. So what happens now? X square dx will be 1 by 3 dt. Wow. X square and dx got replaced by 1 by 3 dt. So what happens now? So this will become 1 by 3 dt and log t. Now integral log doesn't exist. Derivative of log 1 upon t. But integral log, there is nothing. So that's why I just showed you. Now look at this integral. This is a general. The first sum what we did was general. Look at the second sum. Whenever there is a log function or inverse function as a standalone function, with that there is nothing into it. Because integral log doesn't exist, integral inverse also not able to do by formula method. So log or inverse is standalone. Then if you look at this, I am saying into 1 do it and then do uv. I do multiply by 1 and then go ahead with uv. So let us see now how we do about it. That's the point now. So let us see quickly. Yeah, here we go. So see, log is alone. Integral log doesn't exist. So what I am going to do is, quickly, I am going to do into 1 and then I am going to do uv. Then I am going to do uv. So let us see now. So u integral v dt, because t is there, minus integral box derivative of t, I mean log t, integral 1 dt close dt. I'm sorry, I just put across this point here. Sorry for that. Okay, I'll just take this off. This was x square dx is nothing but 1 by 3 dt. The procedure remains the same there. So now I am doing uv now. So put a box for uv, it will become easier. U integral v dt minus integral box derivative of u integral 1 dt close dt. So I just applied the general uv, but with into 1 I am doing it. So now I think it's very easy now. 1 by 3 as it is applies to the full bracket here. So log t as it is. Integral 1 is with respect to t is t minus, I told you, solve this first, 1 by t dt. Cancel this t here. So I think again integral dt. So 1 by 3 t log t. You're replacing, make it look comfortable, minus t plus c. Now put the t and that's the solution for this. So replace 1 by 3, resubstitute, not replace, sorry. T is nothing but x cube and log of x cube minus x cube plus c. One way of looking, you can take x cube common there and then you can work out accordingly. So just understand this, what I did, u integral v dt minus integral derivative of u integral v dt close dt, and then I just solved it out, and that's the way it goes. Have a look at this particular sum, children. It's really a good question there. I really want you to introspect what is there in store. Just have a look at this solution, please, quickly. It might go a little bit longer, but definitely the more long journey, the more better it is. Because in integration, you need to have that confidence and go into the examination hall. Otherwise, it's really going to pull you down like anything. So understand this, children, what we are doing, and the way you look at it, the technique you look at it. So as I said, whenever any sum is given to you, what you are supposed to do is take that and put in the core methods. Okay, I think long division, substitution, and the next part, I believe 14C onwards, is integration by parts, that is product rule. Just have a look at this. Log is a standalone function. There is nothing. Integral log doesn't have integral inverse. This is the inverse sign. This is the inverse sign. Log cot inverse. Okay, cot inverse x. So anyway, once again, remember, you can't do substitution technique. You can't do long division. Then you look at UV kar sakte hai. Now in this case, standalone function is log. So what I'm going to do is, I'm going to do into 1. So I will say integral of log x whole square into 1 dx, and then I am going to pursue u v rule. So let's do it now, guys. So u integral v dx minus integral box derivative of u integral v dx close dx. Now what happens now? This will become log x whole square integral 1 is x minus integral. What is derivative of log x whole square? So it's a simple thing. First find the derivative of the power, then log. Okay. So derivative. So log x square is 2 log x, and chain rule says log x derivative is 1 upon x. Integral 1 dx is x dx. Oh God. I really think about this sum now. Derivative of log x is 2 log x whole square, 2 log x upon x, yes, integral 1. So eventually now this x will get cancelled. So again there is a case of uv there. So x, let me just put across my point, minus this 2 you can take outside. This is again log x dx. Oh God, integral log, what I did integral of log, you did into 1. So I think I can go ahead with do into 1 here, into 1, and then I will go ahead with uv again. So let us do it now. X, so this will become log x whole square minus 2. Now put a box here whenever you are applying uv. It becomes easy for us to simplify and work out with that. Okay, remember we are doing general and log inverse type. 14C and 14D. 14C, not 14D, 14C. So log x. So what will happen? U integral 1 dx minus integral box derivative of u integral 1 dx close dx. Now I will just take the integration there. So this is as it is, x log x whole square minus 2, because remember the 2 belongs to everything. So log x, and this is integral 1 is x. So x log x minus, put this integration sign because you have to solve the inner part. Log x derivative is 1 by x dx. Again now this cancels here. So what happens now? X log x whole square minus 2. Now quickly do it. Now x log x as it is minus dx. 1 dx is x plus c. So my integration is done. You can, one way of looking at this, open this up and then do it. Else you can leave it in the format. No problem at all. Because in the end you should be able to understand what has been done in this particular sum. So this is the solution for this particular sum. Similarly now inverse. Now as I said, when log or inverse is an alone function, you do into 1, children, and then you go ahead. Now immediately now I can do into 1. Now what I am going to do, I will do into 1 here and then do uv here. So remember, as per the Liet rule, this will be u, this will be v, because inverse comes first, then algebraic, right? So I am going ahead now. So u integral v dx minus integral box derivative of cot inverse x integral 1 dx close dx. I really don't know what to do next, because let us see. So this is cot inverse x integral, this is x cot inverse x minus integral, put this dx here, inside sign. What is derivative of tan inverse x? 1 upon 1 plus x square. What is derivative of cot inverse x? Minus 1 upon 1 plus x square. So minus of minus become plus here. I am just going ahead 1 plus x square, and this is x dx. So remember, once the integration sign comes, children, you have to be careful and again look at the techniques what I can do. I cannot do long division because degree is less, degree is more. So what I am going to do, integration by substitution. So 1 plus x square as t, I think because x square derivative is x dx. So wow. So I can put let 1 plus x square as t. So this will become 2x dx will be dt. So x dx is 1 by 2 dt. So x dx got adjusted, guys. So my game changer over. So x cot inverse x plus, hold on, x dx is 1 by 2 dt upon t. What is integral 1 upon x? Log x. So integral 1 upon t dt is log t. So cot inverse x plus 1 by 2 log of t plus c. Replace t and then say he. So what happens now here? This will be x cot inverse x plus half of log of, what is this? This is x square plus 1 plus c. Very interesting, very important and very charming. Keep that in mind. Very interesting. Okay, I hope you got this point clear. So please understand the idea of conducting this revision of complete integration, synopsis, I would say, that every type to be covered, is just to make you more comfortable and understanding how are the techniques applied and when we use those techniques of integration. So here we are on the core methods of integration, children. Okay, so this is what it is, that is the product rule applying to it. This is 14C exercise there. As I said here, 14B is substitution, 14A, 14C is nothing but integration by part, or you can also call it as product rule. Now in product rule there are many patterns. So you saw, right? Now this is 14D. Now I don't want to say 14C, 14D and 14E and all that. I don't want to involve myself. I just want to take you to chart A, core method. Remember what we did? We did general, we did log and inverse as tangent function. Now I come to 14D. This is 14D. Remember 14C is here. I beg your pardon here. 14C here. So this is 14D and this is 14E. Okay. So as we go on, let us see now. So 14D is e raised to x. So whenever the integrand is e is there, sin x is there, along with e cos x is also there, then we don't follow the Liet rule. It's a specific type and a special type of thing which you have to keep in mind. So whenever you see in the integrand, in any integration sign, you see e raised to something. So I believe you check whether it belongs to these two types, because both are there where the integrand has e. So in this case, e raised to x sin x form or cos x. So ex, no Liet rule you will follow in this case. Okay. So let us see how we do the sum whenever an integrand has e raised to x sin x or cos x form. Now how I solve this out, let us see. E raised to x sin x is there, e raised to x cos x is there. Now of course the cos square x, but cos is there, so you have to be careful. Now how I do this type of sum, 14D sums, whenever in the integrand e raised to x sin x form is there, you no Liet rule, okay, no Liet rule. It looks better like this, no Liet rule. Okay. Now how I solve? Listen to the technique and procedure. Whenever you have e raised to x and sin x, or e raised to x and cos x only, not cos square, but it's there, what we do, we will see later on after we do this sum. Whenever, okay, I just missed out something, somebody reminded me. In the previous sum, if you see, whenever log x and cot inverse you do into 1, if you remember the first question, what we did was, what is left out? Inverse. So that's why we did 1 and then we do uv. So let's complete this out quickly there and then I will come to that, sorry. So 1 by 3 u integral v dt minus integral box derivative of t integral 1 dt close dt. I'm just sorry, I just forgot it, I just remembered it, I just put across my point here. So this is 1 by 3 as it is, tan inverse t. What is integral 1 with respect to dt is t minus integral. What is derivative of tan inverse x? 1 upon 1 plus x square. What is derivative of tan inverse t? 1 upon 1 plus t square. Then integral t dt. Now I think I can do the same substitution there. I will say 1 plus t square as u and then proceed. I will say 1 plus t square as u. So t dt will be 1 by 2 du. And then do it. I think you know how to do it with this question. So this is what actually I left out there. So let us not pick up that now. I think the same thing what we did. Okay, now let us look at this question there. Where said whenever in a function e and sine is alone, e and sine are together, e and cos square, I will work out to that, I will come to that. E and sine is together, I don't use the Liet rule. That means, first what I do first, I say let this be I. I am showing you the technique now, understand. I say this as I, that means the value of this is I which I have to find. So I will apply no Liet rule. As per the Liet rule, algebraic L-I-A-T-E, exponential has to be V. Here this should not be V now. So I will take this as U and this as V. That means no Liet rule to be followed. So, and go ahead with the normal product rule, bypass rule. So what happens now? So I will be is equal to, just see now, U integral sin x dx minus integral box derivative of U integral sin x dx, just a clean and simple application of the UV rule. So once you finish with this, let us see what happens here. So I will be is equal to e raised to minus x, integral sine, be careful, derivative of sine is cos, integral sine is minus cos, so don't forget it. So this is minus cos, be careful about the signs, integral. What derivative of e raised to minus x? E raised to minus x is e raised to minus x into minus 1, chain rule, and integral sine is minus cos x dx. So minus of minus is plus here, this sign will remain intact. Now let us see and write down what is left out. So I is minus e minus x cos x, children. Now this minus, because minus is plus, so again integral e raised to minus x cos x dx. The point which I want to mention is when I look at the integration sign, because see, in all the sums, when I integrated further, I got only one term left, so I could integrate end the sum. Here also when I applied, here also integration one term, I ended the sum. But in this case, what happens is, again there is UV rule, because you see two functions are there, so I can go ahead with again UV rule. Now I will tell you why I am doing it, I will just carry on with this. So let us see now what we do. So I is equal to minus e raised to minus x cos x minus, remember I have to apply UV rule, I put a bracket here and then work out. So e raised to minus x, remember the signs are very important thing which the student always go wrong, most of the students go wrong. U integral cos x dx minus integral box derivative of u integral cos x dx close dx. Just applying that basic rule. Now this you do only when e and sine or e and cos are together. Okay. Now no Liet rule. So now coming to the point, what happens now? Let us see now. So I is nothing but minus e minus x. I want you to be a good observer now. Pay attention now. So I am just opening this out now. E raised to minus x, cos x derivative is sin x, integration cos x is sin x, minus, this is sin. Now this is e raised to minus x into minus 1, right? So minus 1 become plus. So e raised to minus x and this is sin x dx. Now wait, don't jump the gun. What happens when I integrated this? I got ex. When I have integrated this, again I integrate. So what means what the sum is toggling between ex sin x to ex cos x, then ex cos x to again coming back to ex sin x. See, in the end I have to stop somewhere, correct or not? So the idea of not following the Liet rule is this, that when you come to this state, what is this e raised to minus x sin x I denoted as I. So integral e raised to minus x sin x dx is I. So I can replace this with I. So what happens now? Let me give it now push there. minus e raised to minus x cos x minus, now be careful, this is e raised to minus x sin x. Now minus or plus is minus, but this is nothing but I. So that's what my idea is, na? To find the value of I. That's what my value is. So what happens now? So minus I will become 2I is equal to minus e minus x cos x minus e raised to minus x sin x. Okay, you can put plus c or minus sign, you can take common here, no problem. But as I am interested in the value of I, so I will be is equal to minus 1 by 2 outside, and you can say e raised to minus x also common here. This will become cos x plus sin x plus c, because the outside sign is taken care of. So what I am trying to tell you is, why I did not follow the Liet rule here, even though you do it, still it's okay. Because the point which I want to mention here is, even I take common out is no problem, because the point is it toggles and I can end the integration at some point. That's the point. Otherwise you keep integrating, it's coming toggling a to b, b to a to b, b to a to b, b to a. It doesn't work that way. Okay? So I hope you got this point clear. Now the question next time, if you see, the question is, can I apply this technique here? As of now, no. Because what is the technique? The technique said that whenever in the integrand there is e sine or e cos, then I can integrate it. But in this case, if you see the sum carefully, it is e, no problem, but there is cos square, not cos. So I have to be careful now. So everybody knows what is, quickly you should know some trigonometric formula. In integration the power is never welcome, right, in trigonometry. So I can say here 1 plus cos 2x upon 2 is cos square x. Right? If you remember the formula, 1 plus cos 2x is 2 cos square x. So I brought this 2 down. So cos square x is 1 plus cos 2x upon 2. So because here it can be a little bit easier for me to handle. Now look at this. So e raised to 2x, this is nothing but 1 plus cos 2x upon 2 dx. Right? Now it's not a difficult task. I can take this 2 outside there and open the bracket. So this will become e raised to 2x plus e raised to 2x cos 2x dx. So remember, as soon as I applied the formula, you can see that first term there is no problem integration. Now the integration applies to all. Now here it belongs to ex sin x or ex cos x form. So again I have to apply this technique here. What my suggestion is, in normal term, this we can put as I2, okay, and solve if you want, and then become easier for us to do. Or you can put this as I. You don't want to put this as I now, so you can put I2, I3 or whatever. Okay, so just to avoid the confusion as of now, I'll put this as I. Okay, now integration, this is not a problem, so I'll just solve this out separately there. Okay, now what I'm going to do is, I'm going to work out for you all. Now just a minute. I just put across this point now. So I'm just writing this out for your comfortness. So e raised to 2x cos 2x dx. So I will put this as I said. You can put I1, it's better, or I2. This is I1 you put, this is I2 you put. I think let us take that I2. Okay, so what happens now? I have to solve this separately there. So I'm solving it, then you can merge out with this answer, no problem. Okay, I hope you got this point clear. Just have a look at this, what is the adjustment I'm trying to do for you all. A lot of you have to be very careful, use maximum space there. So I2 is equal to u integral cos 2x dx minus integral box derivative of e raised to 2x integral cos 2x dx close dx. Be careful about it. So let us do it now. So I2 is nothing but e raised to 2x sine 2x upon 2. Be careful about that. Chain rule. Minus integral e raised to 2x is 2e raised derivative. I mean to say derivative is 2e 2x. Integral cos 2x is sine 2x upon 2 dx. So this 2 and this 2 will get cancelled. So again e raised to 2x and again I have to apply uv. So I am just going ahead and carefully, be careful now, sine 2x upon 2 minus, there is a minus sign here. So when I put a box here, it becomes easy for me to handle it out. So what will happen now? This will become u integral sine 2x dx minus box derivative of e raised to 2x integral sine 2x dx close dx. I am sorry to mess you up with that, but just try to work out with that. Okay. So less space there, less crunch. So I2 will be is equal to e raised to 2x. Now listen what I am doing. Sine 2x upon 2. Be careful. Minus integral sine 2x is nothing but minus cos. So minus of minus is plus e raised to 2x cos 2x upon 2. Now minus is here, okay, I know minus of minus, I will just make it plus here, put the integration sign, this will be 2, this will be e raised to 2x is e raised to 2x into 2, that's why this 2 came here, okay, and sine 2x is minus, so this plus eventually will get back and make it minus here. Minus. Let us do this now once again. E raised to 2x cos 2x upon 2 minus. This is 2, right? 2 and minus of minus is plus. So this will become minus here, minus 2 raised to e 2x and this will become cos 2x upon 2. 2 gets cancelled. Okay, now e raised to 2x cos 2x. What I did? I2. So I2 is equal to e raised to 2x sine 2x upon 2, okay, plus e raised to 2x cos 2x upon 2 minus I2, sorry. So 2I2, so I2 will become 1 by 2 times, this will become e raised to 2x sine 2x upon 2 plus e raised to 2x cos 2x upon 2 plus c. Now, when I come to this sum, this I put as number 1, okay, number 1. So, what I am going to do is, I will just share with you now. Oh, sorry. Okay, let us take the number 1 there. Okay, I come back. So, 1 by 2 as it is. 1 by 2 as it is. What is e raised to 2x? It is e raised to 2x upon 2 plus I2. What is I2? Is this complete set. So what I am going to do is this complete thing I am going to take it and put it over here. That's the final answer. I am sorry, I am not putting, there is a lot of less space there. So not an issue. What is important for me to convey a message today is ki how really we do it, children. That's what is important. Okay, remember as a long lecture you can pause the video whenever you want, right? And you can just take a break and you can continue with that. But remember one thing, one set when you start your complete understanding of this, that's important. So this is nothing but 14D. So in 14D, as I said, in 14D I had said core methods are crucial there for us. In core methods, general we did, log inverse alone we did. This is nothing but 14D. Whenever in the integrand there is E and sine or E or cos, E sine square, cos square, no. Okay, E sine, E cos, anything, cos of any angle, you can always go ahead with this particular technique of integrating, putting this I and not following the Liet rule. Keep that in mind. Okay, I hope you understood this point. Two variations I showed you. One is e raised to x sine directly, one is e raised to x but cos square. So I just applied this formula trigonometric and then converted it. And then I was in a comfortable zone solving this out, but not comfortable in putting this on the screen. Okay, so just make a note of it, children. Pause and note it down and understand what we did. This is nothing but 14D. 14D. Just have a look. Techniques, understanding techniques are important there. Last part after this in core methods I am talking for 14E. Now how we do 14E? Let us see this part clearly. What you see again, now I don't want to take you to the sum, I want to take you to my chart A, core methods. Look at this method. Look at this method. Very easy, very interesting and good one also. In the integrand there is e raised to x, but there is no sin x or cos x form. There is a function and derivative, both exist. That the answer is e raised to x fx plus c. I am not showing you the method here, I am directly showing you the technique. So whenever a integrand has e raised to x fx plus f dash x dx, the answer for this is e raised to x fx plus c. What I mean, I will just explain to you with the examples. Ex is there. So as I said before also, whenever in the integrand e raised to x is there, you have to always presume that sin x and it is a function and the derivative is there or not, or ex sin x cos x form is there or not. Either of the two. First you check that. So e raised to x is there. If you look at this, this is the function. And what is derivative of sin inverse x? It is 1 upon. So function and derivative along with e raised to x is there. So whenever in the integrand e raised to x, function and derivative both exist, then the answer is e raised to x fx plus c. The answer is e raised to x fx plus c. Keep that in mind. So guys, so here we go, e raised to x fx plus c. So it's a clear-cut case. So what you tell the teacher? Teacher, this is e, this is function, this is derivative. So teacher just explain this rule, which is equal to e raised to x fx plus c. So my answer quickly here is e raised to x and fx. What is fx? Sin inverse x plus c. So you're able to identify that. That's the important thing which you need to keep a note of it. Okay? I hope you got this point clear. Now let us take the next one. Now here I can't tell you any clue in this sum. There is no e, so I am not going to look at that pattern. So let us talk about long division, core method. Long division out of question. Substitution out of question. UV out of question because it's sine of an angle. So UV out of question. I have a doubt here. Okay, now I am going to use little bit of different. So as I said in the previous sum, whenever no core methods apply, what I suggest is go with basic mathematics. So I am just trying to think log x as t. Suppose if I put log x as t. Okay, if I put log x as t, so I will just put this. I am not taking the derivative there. If I put log x as t. Okay, let us do this. 1 by x dx is dt. You might ask me, so dx is nothing but x dt. Oh God, the adjustment is something different really. Okay, I am coming to this. I will show you what I mean. Now look. So this will become sin t plus cos t. Now hold on. Okay. Now dx is x dt. But if dt comes, the x has to be cut down and shown something else. So this is e, right? So from here, can I say x is e raised to t? Because this base comes and take it by its horns. Why I did that? Because once dt comes in the picture, the x has to be replaced by e raised to t. So that's what sin t cos t. This dx is, this dx I can say now e raised to t dt. Because x is e raised to t. So in short, this is e raised to t dt. Now I am in a comfortable zone. Why? Because you can see this is e raised to x, fx sin derivative is cos, so f dash x format is there, right? This format is there. So that's why, some sums, I would not say, but namely it happens for log and all those things. Be careful about this category of sum, okay? Because teacher will never give you this direct sum, okay? They always will try to confuse you all by putting this, but just by a small application of mind, I think this sum falls down like 9 pins. So this is the tell the teacher Ex Fx plus F dash x format is there. Therefore, the answer is Ex Fx plus C. So this is what you have to tell the teacher, then apply the formula. Because sine is a function and this is the derivative. So I can say the answer is e raised to t sine t plus c. But t you have to replace that. So e raised to t is nothing but log x. Now there is a way here. So sine of log x plus c. Now I want you to be a good observer here because there is something more I want to do. There is a basic rule in logarithm. If suppose a log of something, a raised to log of something to the base a is there. If the bases are same, then this simplifies to fx. So similarly here, remember there is e over here. The bases are same. A raised to log of fx to the base, so this x will come down. So in short, the answer will be x sine log of x plus c. Remember, you might ask me, should we do it? Yes, I want you to do this step. Yes, I want to do this step. Okay, I don't want anyone to miss out on anything. Remember, this is basically based on the last exercise, that is 14E. Please try to understand this. Try to work out with this. Try to really catch up with this. So remember, all the core methods we did. Yes, now a simple thing comes up now after this. Core methods we did. What is the core method we saw here? So that is nothing but degree of the numerator bigger than the degree of denominator, not longer, sorry. Long division. Function and derivative with their substitution. UV, Liet rule, and then we work out. I hope you understood, you really catched up all the core methods. How and when we do your camera and scan this out, whatever we had completed till now, it will come up, okay? And just understand this, how we had done, how we did.